Hello, in this in-class activity, we are going to demonstrate the calculations involving normal distribution table. So far, we have doing calculations related to normal distributions by using some kind of charts. Today, we're going to learn how to use a normal distribution table to do the calculation. And also, we have known that there are two types of calculations related to normal distribution. First type of calculation involves we are given the known value of variable x, and we convert that x values into some sort of z-score. That is, we have to find out for that x value how many standard deviation it is from the mean. Then we look up chart to determine the percentage values. Let me use one example to show the process. In this normal distribution with the mean 78 and the standard deviation 6.3, what percentage of observations are between 59.1 and 96.9? And in this distribution, we have two known values of variable x, 59.1 and 96.9. We are required to decide what percentage of cases are located between this lower bound and upper bound. And we know that to find out answer, we need to determine 59.1 is how many standard deviation from the mean, and 96.9 is how many standard deviations from the mean. And to determine that, we need to do this type of calculation, 59.1 minus the mean divided by the standard deviation. That gave us -3. So we know that 59.1 is 3 standard deviation below the mean. And similarly, we do the similar calculation to determine 96.9 is how many standard deviation from the mean. We did the calculation and find out the answer gave us -3. So the +3, so 96.9 is 3 standard deviation above the mean. And given with these two pieces of information, 3 standard deviation below the mean and above the mean, we go to the chart, 3 standard deviation below the mean and above the mean, that corresponds to a percentage 99.74%. So that give us answer. So we know that there are 99.74% cases are bound between 59.1 and 96.9. In this process, we actually follow these 3 steps. We first, based upon the value of x, we calculate this value -3 and +3. We call these are z-scores. Z-scores basically tell us for a particular value x, how many standard deviation it is from the mean. Also, is it below the mean or above the mean? So this is the formula we actually used. Okay, we use this formula in our calculation here. And the second step, we look at the chart to find out the associated percentage number, and that number may be the one we need directly or may need some further calculation. So this is the first type of calculation that involved. Second type of calculation is goes the other way around. We are given a percentages, and we need to convert a percentage into a z-score, and then from the z-score we calculate the original value of variable x. Now again, we use one example to illustrate what I mean here. In this distribution between what two values do the middle 68.26% of observations fall? Now we have a known percentage value here, 68.26%. This percentage is bound between x1 and x2, And this question is about what are the value of x1 and x2. So that is from the known percentage. Eventually, we need to figure out what are the value of original variable x. Yeah. And to find out answer, we need to determine x1 and x2 how far they are from the mean in terms of a standard deviation. How many standard deviation are there from the mean? The clue here, the key here is this percentage number. Based on this percentage number, let's go to this chart again. 68.26% correspond to one standard deviation below and above the mean. This one standard deviation below above the mean is actually tell us so-called the z score. From that chart, we know that x1 is one standard deviation below the mean, x2 is one standard deviation above the mean. Therefore, we can calculate the value of x1 and x2 by using this formula. In this formula, mean minus 1 times standard deviation. 1 tells us that x1 is 1 standard deviation. Negative sign means it's below the mean. So you follow this formula and plug in the number 78 minus 6.3 give us 71.7. So x1 is 71.7. For x2, we follow the very similar formula, except here is a positive sign that refers to the fact that x2 is above the mean. So it's one standard deviation above the mean. Okay. We follow through the calculation, we obtain value 84.3 to obtain the value of x2. Now, in this process, we basically following these 3 steps here. First, we determine appropriate percentage number. Now, 68.26% is the value that directly relevant in this question. But sometimes when we won't be given those percentage number directly relevant in a question, we have to first do some calculations to come up with a relevant percentage number. Then we go to a chart to find out the corresponding z-score. That is, we need to find out x1 and x2 how far they are from the mean in terms of a standard deviation. Then we bring the result into this formula to do the calculation. And this formula looks new, but it's not new. We have learned this z-score formula before. Now you just switch term to change the form, derive this formula we use to calculate the original value of variable x. So these are 2 types of calculations so far. Now, again, in the past, we use this chart as a help in our calculations. But this chart gave us the percentage values here and the corresponding information about the standard deviation or z-score, and 1 standard deviation corresponds to this percentage number, 2 standard deviation correspond to this percentage number, so on, so forth. Now, today we're going to use a normal distribution table. Normal distribution table is more general than this chart. This chart only contains the percentage number that correspond to 1 standard deviation, 2 standard deviation, and 3 standard deviation from the mean. For this table, you do have information concerning 1 standard deviation, 2 standard deviation, and 3 standard deviation from the mean. But you have also 0.1 standard deviation, 1.8 standard deviation, 2.9 standard deviation from the mean. So this table is more general, that contain a lot more information than this chart. So the calculation that we are going to demonstrate today involves more general type of calculation that are concerning normal that concerns normal distribution. All the questions in today's demonstration are based upon the normal distribution with the mean 78 and standard deviation 6.3, except question 7 and 12. Okay. First, let's do first type of calculation from the known value of variable x. We convert that into z-score, and then from z-score we find out the corresponding percentages following these three steps. First question, a score is 86.3. How many standard deviations is it above the mean? This question is just a practice. We practice to calculate standard scores here. Let's first draw a diagram. It's very helpful to draw a diagram. A diagram will help you to understand what question is asking. Okay, so I ask you when you come to do your assignment, you also draw a diagram first. 78 is a mean, 86.3 is larger than 78, therefore we draw it to the right of 78. Also label the horizontal axis with the variable x, showing that this is the distribution of variable x. Now, this is a question, is a straight application of z-score formula. Z-score is the x-score minus the mean divided by the standard deviation. Now, this order cannot be switched. You cannot put the mean first, the x value second. You cannot switch this order arbitrarily. It has follow this order in order to get correct sign. Okay, and then you plug in the value 86.3 minus 78 divided by 6.3 is 1.32. So 86.3, this x value is 1.32 standard deviation above the mean. The positive sign means is above the mean. Second question, a score is 56.1. How many standard deviations is it below the mean? Again, we draw this diagram to show 56.1 is way below the mean, and we put, again, write down the formula first and followed by the actual value. So we obtain negative 3.48. So 56.1 is 3.48 standard deviation below the mean. Okay. Question number 3. What percentage of cases falls between 78 and 90? Let's draw this diagram first to understand the question. Now, we have this interval bound by the mean and value 90. The question is about what percentage of cases are bound are located within this interval. And first step is to convert this 90 into a z-score. We want to see 90 is how many standard deviations from the mean. Okay, and this is the formula followed by the calculation. We obtain a z-score 1.9. So 90 is 1.9 standard deviation above the mean. Then we go to a normal distribution table. This is a normal distribution table. The first column gives us a z-score. Like 1.9 is a z-score. And also you look at this heading here. This heading has a little diagram, little shaded area extending from the mean, from the middle to a particular z-score. That tells us the way that this normal table is made is to use this percentage number in the field refer to this particular area that starts from the middle of the distribution to a particular z-score. So this shaded area are those percentage values. Now in our question, we have a z-score 1.9. let's see what percentage value correspond to 1.9. 1.9, as you can see, uh, the value of the z-score here refer to this z-score here. All this percentage number refer to from the middle, from the mean to a particular z-score. So if we have a z-score 1.9, we can read what percentage number correspond to 1.9. You could have a z-score 1.90, 1.91, 1.92, so on and so forth. You have different decimal places. But in our case, it's simply 1.90, and so the decimal second decimal place is simply 0. So you look for this 0.99 is 0.00, and this column with the heading 0.00, and then you read 1.9 to the right to across this column, and this percentage number correspond to a z-score 1.90. So 4713 or 0.4713 or 47.13%. This percentage refer to an area that started from the middle to this z-score 1.90. Okay, so this percentage number 4713 refer to this here this area from the middle to a particular z-score, or from the mean to a value of x 90. So we look at the normal distribution table. We determine that the probability for a z-score fall between the mean 0 and 1.90 is 4713, 0.4713. Okay. So we know that a corresponding percentage for x between the mean and the 90 is also 47.13%. Now, in your assignment, I'll be looking for several things. I'll be looking for your work. That includes this diagram, the formula, and the corresponding calculations. These steps, you find out that number from the normal table. Then finally, you express the probability relevant to the question in correct mathematical notation. Yeah. You need to show all these steps in your assignment.